My screen is visible, right? Is it visible to you, students?
Yes, ma'am.
Correct.
Yes, ma'am.
Students, we discussed first 5 experiment, which is basically depending upon the instruction group, right? We discussed data transfer group and we had a task based on this. Then we discussed about arithmetic logical group. We had discussed about branch related operation, and all the experiment was based upon this basic exercise, right? Now, if we'll focus, if we'll observe from experiment number 6, basically that is focusing on application based. Say for example, counter we discuss. Okay, suppose if we are designing a counter, how to design? Second is generally whenever we want to repeat the task, instead of repeating it manually, you can set a counter, you can decrement it after performing each and every task, and finally you will check through condition whether your final count is zero or not, right? So that way, 2, 3 application already we had discussed. Now, today we want to discuss about experiment number 6, which is basically depending upon this designing of counter and the limitation of counter whenever you are designing in the observation. Say, for example, students, suppose if I am designing a down counter which will count from 10 to 0, right? We observe this kind of counter at so many places, right? हम लोग ने काउंटर तो सभी जगह पे देखा है, which will count either up or down, right? Suppose if take an example of down counter, you are observing, you are counting from 10 to 0 every time you will send your number onto the display, you will observe it, you will decrement it, again you will update, and finally you will check whether your counter will become 0 0 or not. If it is 0, then you will come out of the loop if you are not designing a continuous counter. अगर आप continuous counter design कर रहे हो तो 0 0 के बाद again it should be loaded with the maximum count. Are you following my discussion, student? Right? We had observed at so many places where there is an requirement, or we had observed that counter is used, right? Suppose if you say તમે તમારા ઘરના હોમ અપ્લાયન્સીસ ઓબ્ઝર્વ કરો, right? They discuss the application of a traffic light, right? So every time we observe, there is an counter which will count down or count up depending upon the application. So generally, what is the flow or what is the process that we are following? That we are having some count value. We will send this count value to the output port. Then we will decrement it. Again, we will send it to the output port. Again, decrement. Again, send it to the output port. So ultimately, we are putting it into a loop and we are checking whether a final count is 0 0 or not. अगर मैं continuous counter design नहीं कर रही हूँ, then I'll come out of the loop. If I'm designing a continuous counter, then what I'll do is after 0 0 again I'll go and reset my counter or load my counter with the maximum value. So this is a general flow, right? Now, whenever you are designing a counter, students, have you ever observed कि हम लोग को दो काउंट के बीच में there is some finite time delay? Have you ever observed there is a requirement? There is a requirement where we need to put some delay in between to count. Suppose if I'm designing a counter, it will count, it will send it to the output port, it will display, again it will decrement, display, decrement, display. If I'm not putting sufficient delay in between to count value, what will happen? Are you following my discussion, student? Suppose अगर मैं दो काउंट के बीच में if I'm not putting sufficient delay, then what will happen? Yes. हर्ष, what do you think? What will happen? पार्थ, अगर मैं दो काउंट के बीच में if I'm not putting enough delay, then what will happen? Janvi, what do you think? Students, are you getting my voice? Yes or no? Am I audible?
मैम ओवरराइट થશે ડિસ્પ્લે ઉપર.
Okay. Display પર override થશે. There can be a one answer. Okay. What do you think, Janvi? What will happen? The question is, if I'm not putting enough delay between two count values, suppose 10 or 9 के बीच में, if I'm not putting sufficient delay, what will happen? Yes? Janvi, are you getting my voice? Yes or no? Okay. So what is your answer? Are you following my discussion?
Not getting question.
Yes?
Not getting your question.
Suppose you are designing a down counter which will count down from 10 to 0, right? 10 to 0 matlab 10, 9, 8, 7, 6. In between two count values, suppose if I am not putting sufficient delay, अगर मैंने 10 और 9 के बीच में कुछ डिले पुट नहीं किया तो क्या होगा? What will happen?
Direct jump to 8.
It will directly jump to 8. Okay. So it will skip in between value. That what your answer is, Shanvi?
Yes, ma'am.
Okay. What do you think, Pooja? Ritesh, are you getting the discussion? Suppose, student, if I'll say, let's try to understand through simulator. Suppose if I'm designing a counter, let's say for example, MBI A09H, what I'll do is now, I'll decrement my count, and before decrement, I will send it to the output port. Let's say, right now we are not sending anywhere decrement A. कहाँ तक ये मुझे काउंट करना है फ्रॉम 9 to 0. If it is 0, then I want to come back. I want to stop my execution. Right? Are you able to understand, student? यहाँ पे हम लोग ने क्या किया? Initially, we are loading our register A with 09H. We are decrementing it. So it will become 09, then it will become 08, 07, 06. कब तक ये मुझे काउंटर स्टार्ट रखना है? जब तक ये 00 ना हो जाए. So I'll put the condition JN said if 0 flag is not set, then go and decrement it. If it is set, then hold. Now just try to understand. My screen is visible, right, student? Yes or no? Okay. Yes. Now just check it step by step. You will identify that it is working properly. 9, 8, 7, 6, 5, 4, 3, 2, 1. Because manually I am giving the delay. Now just try to understand. If I'll run this program, can you observe here anything, students? Can you observe it? Observe here anything? Yes or no?
No.
Why? What is the reason? Because there is no sufficient delay in between two count value. Alright? यहाँ पे 9 होगा and then see here you can see कि मैंने assemble किया run all at a time. तो वो execute हो रहा है but we are not able to observe it. Right? We are not able to check the values. Why? Because we are not putting any delay in between two count. Right? आप देखो manually it is working. Right? Why? Because manually we are providing a delay, right? मैं जब click करूँगी then it will execute. But if you are going and executing it run all at a time, you will observe that you will not find any count value. The reason is we are not providing any delay, right? So that was the concept of our experiment number 6, where we want to discuss, how to provide timing and delay operations, right? Suppose if you say you want to provide a delay, you want to set some finite time in between two count. What can be the different technique, that what we want to discuss. Student, now onwards हम लोग ने ऑलरेडी वी हैड डिस्कस 6 modules, right, 6 chapters. Now 7th chapter, this from Ramesh Thankar book we are studying right now. I'll not repeat this in our lecture. So पैरेलल में अभी 2 चैप्टर चल रहे हैं. If you'll observe स्टेक एंड सबरूटीन हम लोग क्लास में कर रहे हैं, and timing and delay they are observing here in lab, right? So make sure you all will remain present and you will make a note of this, because it is not anyway going to repeat in class, right? So now very important to understand, student, the reason whenever we are designing a counter or any application like counter you are taking, and if you want to provide a delay, what can be the different technique that we want to discuss here in this chapter, right? So basically outline of this chapter is, first of all we'll design about counter, we will check about counter. Now if you remember in our last lab, we had already discussed how to design a counter. Now there is a question how to provide a delay in between two count. Then we will discuss some program based upon this two application, this two concept. We will design a counter and we will put some time delay in between two count, right? And these are some programs that we want to discuss here in this chapter. Now student, counter we had already discussed. Just one more time for your revision. Whenever you want to design a counter, what you will do is, first you need to decide whether you are designing a up counter or a down counter. Counter that will count some value. Now which value you want to count, that first you need to decide. Whether you want to start from 0 and you want to reach to some value, or you want to load your counter with the maximum value and you want to decrement and you will reach to 0, right? So depending upon the application or depending upon the requirement, you may have two options to design a counter. Either you will design up counter or down counter. Am I clear, student? Right? Suppose if you say you are designing some counter, which will initially take the value 0, 0. Every time with the count value, you are incrementing it, and suppose you want to stop at FF. So what you will do is, you will take 0, 0 inside your register, you will increment your register. Every time you will compare it with FF. Try to understand this discussion very clearly. You will compare this value, your predefined value, which is FF. Now you will check whether your predefined value and count value are same or not. If it is same, will come out of the loop. If it is not the same, then you will again go back and increment. So ये आपका कौन सा counter design हुआ? Yes, which counter we discuss? Initially we are loading with 0, 0. We are incrementing it. We will check whether it will become a maximum value or not. If not, then again it increment. If it is at predefined value, then come out of the loop. So ये out of up and down counter कौन सा counter design हुआ? Yes, Ritesh, what do you think? Which counter?
I think
Yes. दो ही ऑप्शन है, अप एंड डाउन काउंटर. सो व्हाट डू यू थिंक? आप में इनिशियली 0, 0 ले रहे हो? यस, रितेश, गो अहेड.
down counter.
Is it down counter? You are initially taking 0, 0 and you are incrementing it. You will
Up
check.
counter.
It will be up counter. Just try to understand. आप initially क्या ले रहे हो register में value 00 ले रहे हो. Every time you are incrementing your counter, and then you are checking whether it will be comparable with your predefined value or not, right? मैंने suppose मुझे एक counter design करना है which will count from 00 to 10, 00 to 10. What I'll do is I'll take 00 initially, I'll increment it. Are you getting my point? I'll check, I'll compare it with 10, whether it will become 10 or not. मेरा जो काउंटर रजिस्टर जिसमें मैंने काउंटर स्टोर किया है वो 10 पे पहुंचा कि नहीं, that only I will compare. If it is not 0, then again it will increment. If it is 0, then I'll go to the hold. Are you getting my point? So Ritesh, that is known as up counter. आप initially minimum value से load कर रहे हो and then you are going to increment your count value. Suppose if you want to design a down counter, like जो हम लोग generally home appliances में observe करते हैं कि we are setting minutes. Let's say for example मैंने oven में 15 minutes had set, then it will become 15, 14, 13, 12 and so on. That will become 0, 0. Are you getting my point? So that is nothing but the count down. So they are designing a down counter. Are you getting my point, student? Yes or no?
Yes, ma'am.
Yes. So basically, whenever you are dealing with the counter, you have only two options. Either you will design up counter or you will design a down counter. What will be the procedure? अगर आप up counter design कर रहे हो, if you are designing a up counter, you will load your register with the appropriate value. मतलब up counter design कर रही हो तो appropriate value क्या होगा कि initially I'll start with 0, 0. Then I'll increment my register. Suppose if I'm designing a down counter, I'll load my register with the maximum value and then I'll decrement it, right? So basically, while you are designing a counter, you may have two options. You need to select whether you are designing up counter or you are designing a down counter. Then you are establishing a loop, and loop will be repeat if the predefined count and your counted value are same, right? If it will not same, then it will not repeat. And this kind of counter we are using in any home appliances, at a traffic booth. There are so many applications where there is a requirement. हम लोग अपने AC where we are setting the saturation value, we can decrement, we can increment, temperature controller, right? Industry में जहाँ पे भी in short we want to design a counter, there is a requirement to design a counter. We need this concept, right? Now this flow chart will give you an idea कि generally हम लोग क्या करते हैं. This is to design a counter. This flow chart will help you to understand how to design a counter. वैसे हम लोग ने डिस्कस किया, but just try to understand it through flow chart. We will initialize it. We will initialize the value. We will display it. We will update. Is this final count? If yes, then we will go to the end. If it is no, then we will again go and display. For example, up counter design कर रहे हो, initialize it with 0, 0, display it onto the LCD, LED, 7 segment जो भी आप यहाँ पे display device लगा रहे हो. Students, my voice is okay. Can you hear me properly? Yes. Students, can you hear me properly?
Yes, ma'am, you are audible.
Okay. So initially we are taking the value 0, 0 in case of up counter, we will display it. Then we will increment it. Whether is final counted, that we will check through comparison. If yes, then we will end. If no, then again we will go and display. अगर आप down counter design कर रहे हो, we will initialize it with the maximum value. We will display that value. We will decrement it and we'll check whether it will become 0, 0 or not. If yes, then we will come out of the loop. If no, then again we will go and display. Any doubt here in this slide, anyone? Are we able to observe? Are we able to understand this? Yes or no? Correct? Any student, any last point to discuss with this slide? Okay. Now
Okay.
it's clear. Now student, if you had observed we discussed कि जब भी आप काउंटर सेट कर रहे हो along with the application that we discussed, you always can use this counter to repeat your task, right? For example, मुझे multiplication करना है, so what I'll do is 5 into 4 करना है, so I'll repeat the task of addition 4 times. I'll add 5 4 times, so that will give me the equivalent result. So मैंने multiplication में addition का task 1 2 3 and 4 times किया, so that what I can do with the use of counting, right? Initially मुझे addition एक बार कर लेना है and I'll set my counter with the maximum value. Then every time after addition, I'll decrement my counter and I'll check whether it will become 0 or not. And that way we are able to repeat our task through counter inside our program, right? And there are so many programs based upon this we discussed in our last lab experiment number 5, जहाँ पे हम लोग ने, if you remember, हम लोग ने क्या किया था? Order में we had arranged in ascending order. We had find positive and negative numbers. We had performed the program of multiplication through counting, right? So ये part हमने already experiment number 5 में कर दिया कि जहाँ पे the counter can be used to repeat your task multiple times inside your program, right? If you remember, हम लोग ने ये सारे programs किए थे कि जहाँ पे if I want to perform a multiplication operation, I'll perform addition of that number and that ultimately give us a multiplication, right? Now student, today we want to discuss the delay, how to provide a delay in between two count. मतलब हम लोग दूसरी पैरेलल एप्लीकेशन को देख रहे हैं. एक काउंटर का एप्लीकेशन है. Whenever you want to repeat your task, you will set a counter and you will repeat your tasks, your counter times. Now parallel जो हमने एप्लीकेशन डिस्कस किए थे, where we are designing a counter and there is a need to put some delay in between two count value, what can be done? Now as we discuss, suppose you are designing whether up counter or down counter and you are not putting sufficient delay in between two count, there is always problem that you will check for first count and you will directly jump to the last value, right? In between count value you are not able to observe due to insufficient timing, right? आपने जो time delay provide किया है in between two count value, that is not sufficient, so that's why you are not able to observe it. Now student, can anyone tell me कि जब भी हम लोग काउंटर डिजाइन कर रहे हैं and in between two count value I want to provide some delay, what can be the technique or how you will decide that this much time is spending in between two count value? How you will check? Should I repeat my question, student, or are you following it? My question,
Yes,
yes.
repeat.
Yes. My question is, suppose if you say you are designing a down counter, you are designing a down counter where you are counting from 10 to 0. So 10 or 9. Right? So आपका जो 10 count आप display कर रहे हो और जो 9 count display होगा, in between that you need some delay. The question one is, what do you think how that delay we can provide? Second is, suppose if you say you are providing a delay, how you will decide, how you will calculate it? Janvi, are you getting my question? It is in two part.
Yes, ma'am.
Okay. So what do you think, students? Rumel? Be on time. Shreya, be on time. Okay, Ritesh, what do you think? It's okay. What is your understanding? My question is, पहले first part का आंसर दो. Suppose if I'll say I'm designing any counter, let's say for example down counter, I'm count down from 10 to 9. I want to provide some delay in between to count. So what do you think? What can we use? How can we provide a delay? Yes? Students? Not that much difficult. Don't overthink. It's very simple. Ritesh, Chanvi, Rumil, Harish, Parth. What do you think? Pooja? Yes? Chanvi, what do you think? Any answer? Any rough idea?
No idea, ma'am. How to put time in between.
So, first thing, yes, Ritesh, how look? Unmute and talk, it's fine. No need to write. So, ultimately, yes, Ritesh. Bye.
We generate the counter. Suppose any down counter, like can use decrement, and then we can use the the loop instruction, uh, and that loop duration will, like, it will the time of delay.
Okay. So, Ritesh, your answer is almost 50% correct, but that is the answer of second question, how to provide. Right? The question is, students, suppose if I say I'm designing some counter and I want to put some delay, तो डिले वर्ड से आपको ये पता चलना चाहिए. सपोज इफ आई से आई वांट टू पुट अ डिले, दैट मीन्स देयर इज नो ऑपरेशन शुड बी परफॉर्म, ओनली द पासिंग ऑफ टाइम शुड बी देयर. आर यू गेटिंग माय पॉइंट? अगर 10 से 9 हो रहा है एंड दैट 9 आई वांट टू डिस्प्ले एंड इन बिटवीन 10 एंड 9 आई वांट टू प्रोवाइड सम डिले, मतलब इन बिटवीन कुछ टास्क नहीं होना चाहिए, देयर इज नो updation or there is no process, it will simply pass my time, right? So delay matlab kya? You are holding your data for a certain period of time, right? So you may have some technique which will help you to hold your data for some period of time. Are you getting my point? Suppose computer or printer का आप example ले लो. Whenever you are printing, तो आप जितना your computer is sending the data to a printer, what do you think your printer is able to print that much fast? Yes or no?
No, ma'am.
No, it's not possible, right? Your processor will send, your computer will send data, but your printer is not able to take the data that much with that much speed. So if you have observed ever, there is a buffer in between our printer and computer, right? So कभी आपने एक ये मैसेज भी आपने ऑब्जर्व किया होगा कि बफर इज फुल, बफर इज फुल. व्हाट इट मीन्स? दैट बफर विल होल्ड टेम्पररीली योर डेटा. Your output and input are exactly same. Simply, it will provide a delay in between your input and output. Right. So there is a buffer-like thing which will provide a delay in between two count. Right. तो जब ये buffer I'll speak, that is basically designed. That will basically a device which will provide you a delay. ये हम सॉफ्टवेयर से प्रोग्रामिंग से कैसे कर सकते हैं? So that we want to discuss. Right. So just try to understand the procedure used to design a specific delay is similar to set up a counter. Right. Now how it is similar, just you will understand within next slide. The register is loaded depending upon the delay required, and that will not perform anything. It will simply increment or decrement your value, and that value will be incremented or decremented by a count value and ultimately that is nothing but that we are doing for nothing but the for the passing of time we want some delay in between two counts, so that's why we are writing some loop is Ritesh discussed कि हम लोग कुछ loop लिखेंगे जो basically कुछ करेगा नहीं but it will provide a delay, and the time delay we are getting in between two count value. So basically to provide a delay also, we'll set this, we'll use this concept of loop, right? Ritesh next sentence bola loop is an program or loop is an instruction. Ritesh, make sure loop is not an instruction, but inside loop you are writing your instruction. Ritesh, are you getting me? Right? Whenever you are setting the loop, is available or not? Yes. So inside the loop, we are writing some set of instruction and that we are executing, right? So for example, अगर मैंने ये काउंटर डिजाइन किया है 09, I am decrementing. Suppose after decrementing or before decrementing, I am sending it to the some output code, and then I am decrementing it. I am checking whether it will become 0 or not, and I am setting it, right? So student just try to understand कि हम लोग ने ये जो काउंटर डिजाइन किया है, we are not putting any delay in between two count. तो मतलब कि ये मेरा डिस्प्ले हो रहा है आउटपुट कोड 2 पे, right? Whatever my count value is that I am sending to the output code and I am decrementing it. In between this, I need to write some loop which will execute for a certain finite period of time, and that is for nothing but to passing my time. Are you getting my point, student? यहाँ पे जो मैं loop put करूँगी वो कुछ काम नहीं करेगा, but it will only be used to provide a delay in between. आप जो अपना रजिस्टर ले रहे हो और उसको डिक्रीमेंट कर रहे हो, उनके बीच में आप कोई लूप पुट कर रहे हो, so that loop will execute depending upon the timing requirement that you need, and then it will decrement and it will check and it will send to the output code. So certain set of instruction you need to write in between two counts, so that will be a finite time that you will get in between two count value. Are you getting my point, student? Yes or no? First make it clear. Are you getting the discussion? Acknowledge if yes.
Yes, ma'am.
To Janvi, it's clear. What about remaining students? Are you getting the discussion? Only one student is understanding. Everyone has to acknowledge. If yes, then you can say yes, it's clear. If no, then you will ask the question. What is not clear? Tulsi, Parth, Pooja, Drumil, Harish, Isha, Shreya, Yashvi, Ritesh, everyone. What do you think? Is it clear? Are you following the discussion? Yes? Will not go ahead. To Parth, it's clear. To Krishna, it's clear. So let me remove the remaining students. Only these 3-4 students, they are understanding. So one more time I am concluding कि हम लोग ने first thing discuss किया design of counter. Counter can be used by 2 means. कि अगर आपको inside your program, just try to understand its conclusion. This counter we are designing for 2 different applications. One is if you want to repeat your task multiple times inside your program, you can design a counter, right? For example, I want to multiply or I want to divide the numbers. What I'll do is I'll take initial value and I'll count up or down, right? So that can be a one use of counter. Second is whatever we are observing at our home, for our home appliances or for or any place where you are designing a up or down counter, where there is a need to design up and down counter. So two possibilities to design an up or down counter. To design a counter which is basically up and down. Up counter design करना है तो कैसे करोगे? Janvi, how we will design up counter? थोड़ा जल्दी जानवी.
We will initialize with 0, 0.
Correct. We will take initial value 0, 0, then
Increase it.
we will increment it, then make it fast. Then what we will do? आप काउंटर डिजाइन कर रहे हो, मतलब आपको सेचुरेशन जो आपने लास्ट काउंट वैल्यू रखा है उससे कंपेयर करना पड़ेगा, राइट जानवी?
Is this final value and then
Yes.
go to display.
Correct, right? You need to go and compare. Suppose मैंने आप काउंटर डिजाइन किया है which will count from 0, 0 to 10, right? तो 0, 0, 0, 1, 0, 2 ऐसे इंक्रीमेंट कर करके मैं 10 तक पहुंचूंगी. तो I need to compare my present count with my predefined value 10. Are you getting my point? अगर वो final count तक पहुंचेगा, then it should stop. If it is no, then go and increment. So that can be the one way to design a counter which is up counter. What about down counter? Who will discuss? How to design a down counter? Yes, make it fast. Down counter. क्योंकि इनमें जो स्टूडेंट क्लियर दिख रहे हैं दे मस्ट नो. सो एनीवे दे हैड टू डिस्कस, बट आई नो हाउ मच इट्स क्लियर. ओके रितेश, कैन यू डिस्कस जस्ट डिक्रीमेंट हाउ?
First we need any high value. First we'll initialize the any register with like very high value, and then we will decrement, and then in between we use the loop.
Yes, very good. Right, we will see in both the cases initialization will be different, right? अगर आप up counter design कर रहे हो तो initialization will be the maximum value. If you are designing a down counter, you will initiate with 0, 0. You will display it. You will update your counter depending upon कि आप up counter design कर रहे हो, will increment. अगर आप down counter design कर रहे हो, you will decrement. You will check whether it's final count or not. If it is not, then you will go and display. If it is, then you will go to the hold, right? So that what about a counter. Now as I discussed कि counter का दो use है. One is for the repetition of tasks that already we had discussed. Today we want to discuss about how to provide a delay in between two count, because always whenever you are designing a counter there is a requirement to provide sufficient delay in between two count value, right? And that can be possible through providing a delay. Now just try to understand कि हम लोग जहाँ पे भी दो काउंट डिजाइन कर रहे हैं, in between this two count you need to provide some instruction which will pass your time, which will do ultimately nothing, but it will be used to give you a finite time instances so that you can observe okay, audible? May I audible, students?
Yes, ma'am.
So we want to check few technique which will basically help you to provide this delay, and this technique can be this 4: using NOP instruction, using register technique, using register pair, and by using nested loop or loop within a loop technique, right? So this will make sure that will note it down. What are the different techniques that can be used to provide or to generate a delay in between two count? In between two count, the very first is using NOP instruction, second is using register, third using register pair, and last is loop within a loop or nested loop technique can be used to provide a delay. The requirement must be clear, student. This technique we are using to provide a delay or to generate a delay in between two count value. Are you getting me, student? Now we will discuss it one by one and we'll check for the equivalent example or equivalent program for this. Now using NOP instruction. Now can anyone tell me what is NOP instruction? NOP instruction क्या है? What is NOP instruction? आप लोग जब भी प्रोग्राम कर रहे हो, if your program is not assembling properly, आपने कुछ एरर रखा है प्रोग्राम में, then NOP will display. What is the use of NOP? NOP instruction पता है या नहीं पता है, students? What is NOP?
नहीं पता है मैम.
So NOP is nothing, but as name suggests, it will perform nothing. NOP मतलब no operation. NOP मतलब no operation. You can check here. It will perform nothing, right? It will perform nothing. So it is basically used to provide. As we know कि हम लोग को we don't want to do anything in between whenever we are generating a delay. We don't want to do anything. We don't want to process for anything. We want to simply provide a delay. So if I'll write a set of NOP, for example, मैंने 10 count किया, then I'll write NOP, 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 NOP. So that will give me some finite delay in between two count. Are you getting my point, student? So basically, whenever you are writing NOP instruction, it will help you. जैसे कि मैंने यहाँ पे program लिखा है for the down counter. How to write program for the down counter, that is now known to us. तो यहाँ पे मैंने down counter का program लिखा है, which initially I am loading with the maximum value. I'll send it to the output port, and in between two count I'll write NOP, NOP, NOP. So that basically perform nothing, right? It will not perform anything. The process will not be executed. Any process will not be executed. Only it will use to provide a delay, right? It will use to provide some finite delay in between two count value. I hope you are getting, right? Now, अगर मैं NOP लिख रही हूँ, for example, how much delay I can generate, that is very important to understand. For example, if I am writing NOP instruction 1, it will take how many machine cycle? Can you see here? If you are writing NOP instruction, it will take how many machine cycle?
One.
One machine cycle, which is opcode fetch. So it will take how many T state? 4 T state, right? Yes, opcode fetch machine cycle will always take 4 T state. So अगर मैं यहाँ पे NOP instruction एक बार लिख रही हूँ, so that will generate a 4T, that will be give me a delay of 4T. Now how to find a delay? Try to understand it very clearly. कि T क्या होता है? Your NOP instruction will take 4T. What is T? How we will find T? Yes?
1 by F.
1 by F, right? T is nothing but the opposite of frequency. Clock period you are able to find with the frequency. And we all can understand, or that is known to us, कि frequency, operating frequency is always given to us. हम लोग को हमेशा operating frequency दिया गया होता है. For example, if I'll say my operating frequency is 2 megahertz, what is the value of T? If I'll say my operating frequency is 2 megahertz, what is the value of T?
Millisecond.
How much? Point? Yes, please repeat your answer.
0.0000 or 2 raised to 2 into 10 raised to minus 3 minus 6.
I'm saying that it is 2
0
megahertz.
0.2.
Yes, it's 2 megahertz. That means 1 by 2 megahertz. Ritesh, it is 1 by 2 megahertz. So 1 by 2 is how much? 0.5? Yes or
Yes,
no?
ma'am.
And 10 raised to 6 is 10 raised to minus 6 now in case of t.
Yes, ma'am.
Okay, so it is how much? 0.5 microsecond. 0.5
Yes, ma'am.
microsecond. Are you getting me, student? अगर मेरा AF is 2 megahertz, that is 2 into 10 raised to 6. So 1 by F is 1 by 2 into 10 raised to minus 6, which is 0.5 microsecond. So if I'll say I'm writing NOP instruction, which will take 4 T steps. So what do you think? NOP अगर मैं एक बार लिख रही हूँ, तो it will take how much time? I'm able to generate a delay of how much time? 4 into 0.5,
0.5
which is 2
2 micro.
microsecond. Correct, right? तो अगर मैं if I'll write NOP instructions once, NOP instruction once, I am able to generate a delay of 2 microsecond. Right? You can see here the clock frequency मैंने जो यहाँ पे रखा है, that is 2 megahertz. So delay equal to t state into clock period. So how many t state your NOP instruction will take? It will take 4 t states. So 4 into t is 0.5 microsecond. How we will find this? Try to understand directly from the operating frequency. So whatever operating frequency, अगर मुझे 3 megahertz दिया गया है, then it will be different. So ultimately, the delay I am able to find, that is through machine cycle and t state. So make sure student, अगर आपको machine cycle and t state नहीं पता है, then this will be difficult for you to provide a delay. Right? There is an option कि अगर मुझे 5 to 6 instruction के machine cycle and t state पता है, I'm able to deal with this topic. But make sure that is separate timing diagram also. For that you need to find, you need to check for your machine cycle and t state as well, right? So जब हम लोग ने वो topic किया था timing diagram, at that time also we discussed, very important to understand the timing diagram, right? And we can understand here, this is the application where we have to check how many machine cycle, and from that how much time it will require to execute. Your NOP will take only 4T to execute, so ultimately 2 microseconds delay you will able to generate through NOP, right? So 2 microsecond delay will be generated using NOP, which is the smallest time delay. We can experience here, or we can imagine here कि microsecond में delay मिल रहा है, वो again we are not able to observe. Can you observe microsecond delay?
No, ma'am.
इट्स नॉट पॉसिबल, राइट? सो अगर आप को इसको मिली सेकेंड में कन्वर्ट करना है और सेकेंड में कन्वर्ट करना है, हाउ मेनी एनओपी इंस्ट्रक्शन यू विल राइट? सो obviously whenever you want a delay which is the smallest delay, in terms of microsecond you can go with the technique, right? But it is not always, this technique cannot be always used. Why? Because it will provide a very less delay, right? I hope I'm clear with this first technique. Any doubts, student, here in this?
Ma'am.
Anyone? Yes, please.
આપણે ક્લોક ફ્રીક્વન્સી 2 મેગાહર્ટ્ઝ જ કેમ લીધી?
હા, right. તો
ફ્રીક્વન્સી
ના નો ઇટ્સ અહીંયા તમને ખાલી સમજવા માટે ઇઝી રહે, એટલે જનરલી આપણી ક્લોક ફ્રીક્વન્સી કેટલી છે? 3 મેગાહર્ટ્ઝ, રાઈટ?
હા,
આપણે
3
જે યસ, સો અકોર્ડિંગલી યુ નીડ ટુ ફાઇન્ડ 1/3, રાઈટ?
એટલે એમાં
This
વેરિએશન્સ હોય ને?
યસ, ઓફકોર્સ, રાઈટ? અત્યારે જે બી પ્રોસેસર યુઝ થાય એની ફ્રીક્વન્સી આ ગીગાહર્ટ્ઝમાં હોય, રાઈટ? અત્યારે આપણે લેપટોપ અને મોબાઈલમાં જે પ્રોસેસર યુઝ કરીએ છીએ, the frequency is in gigahertz, right? So accordingly you need to take your clock frequency. આ તો તમને કેલ્ક્યુલેશનમાં ઇઝી પડે એટલે અહીં આપણે 2 મેગાહર્ટ્ઝ લીધું, રાઈટ? But for our processor it is 3 megahertz. And student, make sure कि જ્યારે બી તમને whenever this kind of question is asked in exam, always F is provided to you. હંમેશા તમને S આપેલું હશે, F આપેલું હશે. If it is not given in case, you need to take it 3 megahertz. Am I clear, student? Right? Always F is given to you, right? 99.99% case ma F is given to you. But if it is not given, you will take 3 megahertz because it is an operating frequency of our 885 microprocessor. Right? I hope this is clear. Suppose if I need a 6 microsecond delay, what can be done, students? अगर मुझे 6 microsecond का delay चाहिए, then what can be done? What do you think? If I need a 6 microsecond delay, what can be done with this 2 megahertz frequency? જલ્દી કરો, બોલો. What do you think? 6 microsecond નો delay જોતું હોય તો શું use કરાય? શું કરી શકાય by using NOP? Yes, Ritesh, what do you think? Am I audible? Chanvi?
Yes, ma'am, audible.
What I'm asking you, ki suppose if I want a 6 microsecond delay, what do you think? What can be done? एक NOP instruction, if you are writing it once, you will find 2 microsecond delay. 2 microsecond, 2 more microsecond. So how many NOP instruction you need to write? 3 NOP instruction, right? જે ક્વેશ્ચન પૂછું છું એવો તો ડિફિકલ્ટ નથી હોતો that you need that much of delay, right? Why we are getting that delay? So ultimately the question is, student, कि you need to write NOP manually, whatever delay you required in case of in between two count value. So again, it is providing a very less delay. So basically, this kind of technique, this NOP instruction we can use whenever we need a delay in microsecond, right? So what can be the another technique? Through that you will find delay that can be in terms of millisecond, right? So second method, before starting with the second method, let me ask कि पहली method में कोई ने क्या doubt है? Anyone? Any doubt in first method? Is it clear to everyone? Yes or no? Is it clear? Only you will write NOP instruction, and as we discussed, NOP instruction will take 4T. How we will find T? That is from the operating frequency. That much delay you are able to generate. Are you getting my point, student? First method is clear, everyone? To Janvi, it's clear. Remaining students, okay? Now, suppose if I say, as we are finding very small delay using first, we'll move to the next technique where we are using register to provide a delay. Now, student, whenever I'll say register, we have how many registers? Whenever I'll say register, we have how many registers? હવે આ તો એક્ઝામ આપ્યા પહેલા પછી બધાને આવડતું હોવું જોઈએ, right? How many registers we are having, Parth? Yes. Yes. Janvi, which one?
B, C, D, E, H, L.
Very good. So we have 6 general purpose register, B, C, D, E, H, L. Now just try to understand, take any register, what is the maximum value that you can store into your 8-bit register? If you'll consider any register B, C, D, E, H, L, which is 8-bit register, right? What is the maximum value that you can store into your register?
F.
Very good, Janvi, right? The maximum value, because we are dealing with the hexadecimal number, right? The maximum value that you can load into your 8-bit register is AFF. Are you getting my point, Ritesh? Right? The minimum value can be 00 and the maximum value that you can load into your register is AFF. Right? Now student, if I will if I'm using register to provide a delay, the maximum value that I can use, I can load into my register is FF. Now how to provide a delay using loop, right? That we are trying to understand. कि इसमें हम लोग क्या करते हैं कि we are initially loading our register. You can take any register. You are loading your register with FF. You are decrementing it. You are checking whether it will become 0 or not. If it is not 0, again it will decrement, 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 and it will come out of the loop whenever your this FF will become 0, 0. So if you observe, delay that you are providing through this loop is how much, very important to understand कि ये loop मैंने किसके लिए लिखा है, to provide a delay, right? तो यहाँ पे in before this loop I have a counter equivalent program. Then after loop I'm sending it to the output port. In between to count I'm providing this loop, right? Which will give me a delay. You can see here कि यहाँ पे कुछ ultimately process नहीं हो रहा. Simply we are loading some value into register depending upon the delay that is required. We are decrementing, we are checking, right? So ultimately it will take or it will generate how much delay if I'm writing this loop that we want to understand. पहले ये loop समझ में आ रहा है student?
Yes, ma'am.
Right? Now suppose if I'll say I want to find the equivalent delay that will be provided through this loop. मुझे दो चीज यहाँ पे कंसिडर करना पड़ेगा. एक ये मेरा फर्स्ट इंस्ट्रक्शन जो है वो लूप के बाहर है, that is outside the loop. So this instruction will execute only once, but this instruction will execute how many times? This two instruction will execute how many times?
Until that register becomes 0.
So that is how much? FF, right?
FF.
So yes, so FF in hexadecimal.
255 in this.
Yes, so 255 is a decimal equivalent of this, right? Suppose if I'll say hexadecimal FF, so equivalent decimal, you can say 255. So this I can check here कि अगर मैं ये MVI CFF कर रही हूँ तो फर्स्ट इंस्ट्रक्शन मेरा लूप में नहीं है, दैट इज आउटसाइड द लूप, तो वो एक ही बार एग्जीक्यूट होगा. बट दिस टू इंस्ट्रक्शन विल एग्जीक्यूट हाउ मेनी टाइम्स? Hexadecimal FF, which is equivalent to 255 decimal. 255 times this two instruction will execute. Now, how to calculate the delay? So, जो भी मेरा outer loop का delay है plus जो भी मेरा inner loop का delay है, that two will be combined will give me a equivalent total delay in between two count. Am I communicating student? To find the total delay, what I should consider? Outer loop delay plus inner loop delay, right? Outer loop delay plus inner loop delay. Now outer loop में एक ही instruction है, inner loop में दो instruction है, right? So this two instruction will execute how many times? This instruction will execute how many times? The total of this two will give me a total time delay required to execute this three instruction. I hope I'm clear with this discussion. Any doubt, student, here in this?
Ma'am, inside
Yes, please.
ma'am, in inner loop there are like one that is the counter, so that will take that will be 1 unit of delay, and then this again the loop instruction that will be also 1 unit of delay.
Yes.
So that means
Not 1 unit of delay. If you are writing this instruction, that will take 4 unit of time, 4t. If you are writing this instruction, that will take 10t, right? How you will find this? That is from the machine cycle, right? Not
that
always.
is, yes, ma'am.
Correct, right. So it will not. Yes, you just first you will speak, then I'll give you answer.
Okay, ma'am. So that machine cycle, like if we consider 4 machine cycle as one for one instruction only,
Correct.
then like in previous in case of NOP it was like 2 microsecond.
Correct.
So here there are 4.
There are 4 plus 10. Ritesh, you are not audible.
That okay, that only I'm asking, it is 4 plus 10 or only 4?
No, 4 plus 10.
Yes,
Right?
because
This,
yes ma'am,
yes,
that
this
only is my doubt.
14 T state will repeat 255 times, and the 7 T
Yes,
state will be once, right? So that what you need to consider for the total
so
delay,
that
right?
will be 255 into 10 into 4.
Correct. 255 into 14 into T.
Yes ma'am.
Correct?
Okay, so 10 plus
Correct?
4 into 255. Yes ma'am.
Yes, correct. Right? So just I'm putting here in slide as well so that you can easily understand. आपका outer loop का delay क्या है? 70 state. Why 70 state? Because your MVIC instruction will take 2 machine cycle, opcode fetch and memory read. Opcode fetch का 4 T state, memory read का 3 T state. So ultimately it will take 7 T state. So outer loop delay is how much? 7 into T. So if you are using a processor which is having operating frequency 2 megahertz, so 7 into 0.5 microsecond, which is 7 into 0.5 microsecond, which is 3.5 microsecond. Are you getting me, student? आपका outer loop का delay क्या हुआ? Hello, am I audible, student?
Yes, ma'am. But confusing है outer
Yes, ma'am.
वाला.
नहीं, confusion का कोई बात नहीं है. See, just try to understand. देखो, what you are taking as an operating frequency 2 megahertz, Chanvi?
Yes, ma'am.
Okay, so 2 megahertz is your operating frequency. So what is your T?
What is your T? 4, 7.
T. Only T I'm asking.
T is 0.5
0.5 microsecond, right?
microsecond.
Correct. So T equal to 0.5 microsecond. Just 0.5 microsecond. Now, ये 3 instruction, this 3 instruction you are writing in between 2 count value, right? Out of this 3, ये instruction कितनी बार execute हो रहा है? Only once. While this 2 instruction you are writing in loop, and that loop you are executing how many times?
255.
255 times. तो अगर मुझे total delay find out करना है, if I want to find or T total, what will be T total?
Outer loop delay plus inner loop.
Correct. T outer plus T loop, right? Now how to find T outer? पहले मैं T outer find out कर रही हूँ. तो T outer में कितने instruction है? Outer loop में कितने
One,
instruction?
MVI.
Only one, and it will take how many T state?
7.
7. So 7 into T, which is 0.5 microsecond. Yes or no?
Yes, ma'am.
Okay, so that is how much? 3.5 microsecond, Charlie? 0.5 is
3.5.
eh?
3.5.
Correct. So 3.5 microsecond. That is a delay of your outer loop. Now inside your loop, you have how many instructions?
2 instructions.
2 instructions. So total T states are how many? 4 plus
10.
10. So total is 14 T state. 14 T state you will
Yes.
execute how many times?
255.
255 times. So TL will be, 2 loop will be 255 times 255 times. You are repeating this 10 plus 4, 14 T state. So 14 into 0.5 microsecond. Are you getting my point, Janvi? So what is
Yes,
answer?
ma'am, getting.
Yes, Janvi?
Yes, ma'am, getting.
Okay, what is the answer, students?
14.
14 into 0.5 is 7. So 7 microsecond multiplied by 255 is how much?
One 1785
1785
into 10 raised to minus 6.
1785 into 10 raised to minus 6, which is microsecond. Yes. Now addition of this 3.5 and 1785, how much, Janvi? Because for finding out total delay, you need to add T outer and T loop, right? T outer is 3.5 and 1785. What is the final answer?
1788.5.
Okay, 1788. 1788. So which is equivalent to 1.787 millisecond.
Yes.
Are you getting me, students?
Yes.
Yes or no? Students, are you getting, all of you? Right?
Clear.
Right? So that way we are able to generate a delay in terms of millisecond. Are you getting, student? यहाँ पे हमने almost 1.8 millisecond का delay generate किया, right? We had generated a 1.8 millisecond delay in between two count, right? If we are loading our register with the maximum value, we are able to generate a delay of approximately equal to 1.8 millisecond, right? Now just go through this and let me know in case of any doubt. Just go through this calculation and let me know in case of any doubt. Just I'm putting here. This is the loop. This loop will remain fixed. जब भी आपको delay generate करना है, simply you need to write this loop, right? You need to find the equivalent delay. So how to find the delay? Total T state, T outer, T loop. Now how to find TL? We had already discussed. How to find T outer? We had already discussed. This combination, just combine these two will give you a total delay, and that we had find around 1.787 millisecond. Just go through it. In case of any query, just ask me. कहीं पे अगर कोई भी टर्म समझ में नहीं आ रहा, just ask me. This is a basic. If you understand this, you are able to provide a delay of any millisecond time. Anyone, any doubt? Ritesh, what do you think? Is it clear?
Ma'am, how millisecond?
1787 માઇક્રોસેકન્ડ આવ્યું તારે જાનવી આન્સર?
હા, એ આવી ગયું.
હા, તો પછી એને મિલીસેકન્ડમાં કન્વર્ટ કરતો.
ઓકે, હા, પોઈન્ટ আছে લે. હા,
યસ સ્ટુડન્ટ, એનીવન એની ડાઉટ? જસ્ટ અહીંયા કોઈને કંઈ આ 3 નું કંઈ લોજિક સમજાતું હોય, ના સમજાતું એવું નથી થતું? વોટ ઇઝ ધીસ 3? We had calculated, but we had not considered any 3, right? Student, make sure you need to put a count in decimal, right? FF जो लिख रहे हो तो equivalent decimal is 255, so that what you need to write here in this loop, right? So whatever count value you will find, that always you need to put in decimal. Okay. Student, यहाँ तुम्हें 3 देखाई છે બધાને? Everyone, are you finding this 3? Have you find any logic behind this 3? Why we are subtracting 14 into 255? उसमें से 3 को subtract करें. What is the logic? Yes.
In outer loop we have 70 step.
तो वो तो हमने सेपरेटली रखा है जानवी, दैट इज सेपरेट. जब हम लूप डिले फाइंड आउट कर रहे हैं, राइट, उसमें 14 टी स्टेट मल्टीप्लाई बाय 255, उसमें से 3 को हम माइनस सब्ट्रैक्ट कर रहे हैं. व्हाट इज द लॉजिक बिहाइंड दिस? दैट इज माय क्वेश्चन, राइट? आर यू गेटिंग मी जानवी?
Yes, ma'am, getting.
राइट, यहाँ पे 7 तो सेपरेट ही है, बट ये 14 टी स्टेट में से हम लोग 3 टी स्टेट सब्ट्रैक्ट कर रहे हैं. व्हाट इज द रीजन, रितेश? एनी आइडिया? So make sure student, yes, who is speaking?
No idea.
Okay. Student, जब भी आप JNZ instruction use कर रहे हो, whenever you are using JNZ instruction, if this condition is fulfilled, if zero flag is not set and it will go to loop, it will take 10 t-state. But at last point, 254 times it will execute, it will take 10 t-state. But when you will come out of the loop, at that time it will take 7 t-state. Are you getting me, student? Because at that time there is no need to read this label. जब last time होगा, at that time when this condition is not fulfilled, at that time instead of t 10 t it will take 70 state, right? तो every time हम लोग ने 255 times क्या ऐड कर दिया, हमने 255 times 40 को मल्टीप्लाई कर दिया, जबकि लास्ट टाइम 254 times 14 state will execute, but last time only 70 state will be taken by Z and Z instruction. So that's why we are subtracting this 3 state. Are you getting me, student? 255 times में से 254 times we are executing, we are multiplying it with 14. But last time जब condition is not fulfilled, your JNZ will not take 10 t state, it will take 7 t state जो हमने 10 लेके multiply कर दिया है. That's why they are subtracting 3 t state from this. Are you getting me? Otherwise what you can do is 14 t state you will execute 254 times and one more 7 t state you will add over here. Right? या तो आपको count minus 1 time you will take 14 t state and you will add 7 t state, or what you will do 14 times count time you will multiply 14 t state and then you will subtract 3 t state out of that. Are you getting me, student? Why we are subtracting 3 t state? Yes or no?
Ma'am, but that J and Z will execute one time extra, no? Like when at last when DCR will be executed, then the register C will become 0. So J and Z will again check the 0 flag for the 256th time. So
Yes. No, see, Ritesh, if you will consider it from 0, 0, na? So 0, 0 to 254 is 255 times. Are you getting me, Ritesh? 0, 0 to 254 times is 255 times. Na? You are taking, you're loading your value with 255. So 255
yes, ma'am.
misses,
Yes, ma'am.
right? So, yes, very good, right?
And it
Good
will
question.
be like, yes, because
Yes.
254 values are there including 0.
Yes,
Then
correct.
it is 255.
Yes,
If we'll
correct.
take including 0 255, then it will be 256.
256, correct.
Will be 9-bit.
Yes, correct. Right? Okay. So in like Ritesh, if you have any doubt in your mind, you need to ask. Very good, Ritesh, right? So are you getting the point now? Right? But student, just try to understand कि अगर मेरे पास 3 t state, अगर आप ये subtract नहीं भी कर रहे हो, right? If you are not even subtracting, you will get almost same answer because that is a matter of fraction of microsecond, right? So अगर 3 t state को अगर आप subtract नहीं भी करोगे ना, तो then also it will make no difference, almost negligible difference you will find, right? But we need to understand in our mind that 3 t state we are taking extra, right? जब अभी कैलकुलेशन में तो हम लोग को कोई मैटर नहीं कर रहा, बट whenever we are actually implementing the application, so it may be possible you need to keep in mind कि मैंने 3 t state extra लिए है, so that you need to compensate. Are you getting me, student? Right now we are only dealing with the theoretical concept कि जहाँ पे 3 t state आप लोगे नहीं लोगे will make almost negligible difference आएगा आपके पास. But thing is, actually, whenever you are implementing that 3 t state matters, right? So at that time, you need to always keep in mind that this 3 t state I'm taking extra, so that you need to compensate, right? I hope this is clear. Any doubt here in this, student? Yes or no? Is it clear, student?
Yes, ma'am. Clear.
Okay, so with the first two method we discuss the first technique for generation of delay, which is through NOP, will give us a very less delay in terms of microsecond, almost 2 microsecond. If you consider the processor of 2 megahertz, only 2 microsecond delay you will find. If you can use, if you want to generate a delay in terms of millisecond, you need to go with the second method, where you can generate a delay which is approximately equal to 1.8 millisecond. But student, make sure कि हम लोग ने जो रजिस्टर लिया था फॉर लोडिंग द डिले, फॉर लोडिंग द काउंट, वो रजिस्टर को हमने मैक्सिमम वैल्यू से लोड किया है, मतलब अब इससे ज्यादा डिले आई कैन नॉट फाइंड. आर यू गेटिंग मी स्टूडेंट? राइट, जो भी रजिस्टर वी हैड कंसीडर्ड, दैट रजिस्टर वी हैड लोडेड विद द मैक्सिमम वैल्यू, मतलब आप अभी एफएफ से ज्यादा कोई वैल्यू नहीं वहां पे स्टोर कर पाओगे. दैट मीन्स द मैक्सिमम डिले दैट यू विल गेट through second method is less than or equal to 1.8 millisecond. I hope I'm clear with this sentence. Any doubt here in this? तो अगर मुझे 1 millisecond का डिले चाहिए, I can use this. If I want a 1.5 millisecond delay, I can use this. But suppose if I'll say I need a 2 millisecond delay, then
NOP.
we cannot use this method, right? Then we need to go with the any other method. We can go with the third method where you can delay. You can again with NOP you will find a microsecond delay. तो 2 microsecond, 2 microsecond, 2 microsecond ऐसा आप कितनी बार लिखोगे, right? So that will and that is basically used to provide a delay which is in terms of microsecond and almost 1.8 millisecond delay. But if you want, if you need more delay, you can use last two method, which is using register pair or nested loop within a loop. Student, we will understand this remaining two method in our next lab. But today from this first two method, we want to check for the first task of our experiment. पहले तो मेथड में कोई डाउट है तो पूछ लो. एनी डाउट हियर इन दिस? यस सर. फर्स्ट टू मेथड में कोई भी डाउट है एनीवन? Okay. Now just focus on the first task where we want to generate, where we want to design a counter which will count from FF to 00. The T is given to us, which is 0.5 microsecond. We can use register C to set up the delay. The delay that we required is almost 1 millisecond, and we need to design a counter and we'll send it to the output port. The count value will send it to the output port. Just read this task for a while, right? Take 1 minute time, just read it and tell me what you are interpreting. What is your interpretation for the first task? Yes. If anyone is identified what we want, what we need to do here, just discuss.
We need to create one decrement counter, and every
Okay.
time we decrement, we need to have the output in any output port.
Correct. Right. So very first thing is that we need to identify the type of counter. Rightly said by Ritesh, we want to design a down counter. Generally इसको decrement counter नहीं बोलते, उसको क्या बोलते हैं रितेश? It is known as down counter.
Down
right? Correct. So यहाँ पे student it is given कि you need to generate you need to design a counter which will count from FF to 00. So from this only it is clear कि हमें एक down counter design करना है, right? Now Ritesh, what you mean by continuously? Ritesh, what you mean by continuously? Yes.
Uh,
Yes, go ahead.
like continuously might be the reference to the loop. Like
So with this continuous word you need to understand कि अगर मैंने FF से 00 तक काउंट कर लिया उसके बाद मुझे स्टॉप नहीं करना है, again it should be loaded
Okay.
with FF. Are you getting my point, student? Right? Your counter should design like FF to 00 it will count. When it will reach to 00 again it will load with the maximum value FF. So continuously it should count from FF to 00. वो stop कब होगा? Whenever you will reset or you will stop your execution. Are you getting my point, student? Right? So from this continuous word you need to understand your counter should be loaded with FF to 0, will be loaded with FF value, it will reach to 00, then again it will be loaded with the FF value. Chandy, Parth, are you getting my point, Pooja? Everyone?
Yes, ma'am, getting.
Okay. So you need to design hexadecimal counter क्यों बोला है? Because we are counting from FF to 00. We don't want to design a counter which will only count once, but it should count continuously, right? So that's why you need to take a value FF into your counter. You will decrement it. You will check whether it will become 00 or not. If it is not, again it will go and decrement. But if it is 00, then again it will go and load your maximum value. Ritesh, are you getting me? Right?
yes, ma'am.
Correct. So how to design that counter, that I think everyone can do. Now the next thing is, whenever you are loading your counter with the maximum value and whenever you are decrementing it, right, in between that you need to provide a delay, and that delay is of how much? 1 millisecond. So what do you think, out of those two method, which method you will use to design to generate a delay?
Register.
Second method, right, using register, because we know कि NOP use करेंगे, then only in terms of 2 microsecond we will find a delay. So here we want to generate a delay of 1 millisecond, which is less than 1.8 millisecond. So obviously you can use second method, register method, and then for that you required your F, and here sometime F is given to you, sometime directly T is given to you. Can you see here, student? यहाँ पे directly आपको T दिया गया है, right? That T is 0.5 microsecond. If instead of T, F is given to you, you need to find a value of T, right? So we have to provide a delay in between to count, and that is 1 millisecond. So that you can do with the register, single register method, and that you will put in between to count value, right? So I hope this thing is clear. Now just try to do this, right? Janvi, can you try? Ritesh, can you try? Parts, everyone, right? Can we do this, student? Yes or no? First generator, first design a counter, then try to put that loop of register in between to count value, right? And that will serve your purpose of delay, right? Parth, are you getting me? What we need to do? Vani, Harish, Punch, Mahek अभी ज्वाइन किया आपने? Drumil?
No, ma'am.
Are you getting the point, Drumil? Okay, so first of all, design a counter, and then we will discuss how to put the loop in between two counters. Okay, Janvi done. Ritesh.
Doing, ma'am.
Okay. Ritesh, how are you doing?
Yes, ma'am.
What about remaining student? Part, how are you doing?
Yes, ma'am. Doing.
Okay. Let me know in case of any query, student. पहले तो continuous count design कर लो, then we will understand how to put delay in between two count. Janvi, can you share your screen?
Doing, ma'am. Just a minute.
Mahek, are you doing?
No, ma'am.
Today you are not with laptop, Mahek?
No, ma'am. Today my device is not working well.
Okay. Okay, Janvi, it's okay. How much you did? You share your screen. We'll modify it.
Screen is visible.
Yes, it's visible.
But बट इधर प्रॉब्लम आ रहा है FD FE एंड देन FF देन
So
अगेन FD FF हो रहा है.
correct. So just Janvi do one thing. NVI B आपने B लिया है या D लिया है?
B
B FF then DCRB ये जो
Yes.
अपना ये वैल्यू है ना काउंट वाला उसको
Yes.
लोड कर दो FF से. NVIC
MVIC count.
हाँ उसको लोड कर दो FF इंस्टेड ऑफ काउंट राइट FF.
Okay. FF असेंबल कर दूं? Okay. E E D C B A.
Now can you see
Yes,
your
yes.
counter? Yes,
Yes.
it's working. Now stop it. Now stop it and run all at a time.
Okay.
Can you see, Janvi? It's
Yes, it's
executing. Yes. You are designing a continuous counter where it will count from FF to 00. Again, it will देखो अभी आप 00 होगा then again it will be loaded with FF.
Yes, yes, starting again.
Right?
Yes, ma'am.
So are you all of you are you getting the point? Chanvi, can you share your code?
Okay.
Everyone, are you getting the point? Yes or no?
Yes, ma'am.
So, Janvi, can you explain your code now? What is L1, what is L2, how we are moving?
Yes, ma'am. First loaded with register BFF and decrement B, and then side the counter MVIC with loaded FF and decrement C. जब तक वो 00 नहीं होगा तब तक ये लूप एग्जीक्यूट होगा एंड देन जब B का वैल्यू है वो A में ट्रांसफर हो जाएगा और आउटपुट B एंड देन if parity is even and then go to the loop 1 and then halt.
Parity or 0?
0 sorry.
Correct. Okay, students, code is in front of you. Have you find any mistake or have you find any problem here in this code? Okay, Janvi, it's good. Right? Just Janvi, look one more time with your code. Right? Look and check whether it is working properly or not. Remaining student, you just take a reference and just tell me कि ये कोड सही से वर्क करेगा और there is a problem. Everyone has to tell me कि यहाँ पे ये वर्क करेगा या there is some problem. Mike, what do you think? This code is fine or it is having any problem?
I'm not sure, ma'am.
Janvi, can you identify your mistake? जानवी आप एग्जीक्यूट कर रहे हो व्हाट यू थिंक ये आउटपुट पोर्ट पे जा रहा है या वैल्यू इज गोइंग टू आउटपुट पोर्ट और नॉट हैव यू ऑब्जर्व
नहीं ऑब्जर्व नहीं किया
you just observe it and tell me कि whether you are sending it to the output port or not. Okay, just here I'm checking with Janvi's code so everyone can see. The base is perfect, right? You need to go ahead with this only, right? This few mistake we need to rectify here. First thing is, Janvi, you are loading. Can you see my screen, student?
Yes, ma'am.
Okay. So first thing is you are loading your register B, which is your counter, with the maximum value, and before sending it to the output port, you are decrementing it. Are you getting me? तो क्या होगा? यहाँ पे क्या होगा कि FF में से F ही जाएगा, FF कभी डिस्प्ले ही नहीं होगा. देखो एग्जीक्यूट करो इसको. वैसे भी this instruction is not executing because you are writing ports. Only out you need to write, right? Can we?
Yes.
Out and port address.
Yes.
Okay, now it will work. Now you can observe here. Now देखो आप observe करोगे. Directly क्या आया? F7 EC. Right? That is because your delay is very less. One millisecond का delay है. That's why. But thing is कि आप पहले उसको इंक्रीमेंट लोड मैक्सिमम वैल्यू करके उसको डिक्रीमेंट कर रहे हो, राइट? बिफोर डिक्रीमेंटिंग यू नीड टू सेंड इट टू द आउटपुट पोर्ट. आर यू गेटिंग मी, जानवी?
Yes, ma'am, getting.
ओके, सो यहाँ पे आप डायरेक्टली ए भी ले सकते हो. यू कैन टेक MVI A. You will send it to the output port, out 0 to H. Then you are decrementing your A, MVI CFF. ये आपका लुक किसके लिए है? You are taking that for the delay, right? And then if zero flag is not set, then it will go to decrement. If it is set, then it will go to L1. So instead of L1 here, it should be yeah, it's perfect, right? You need to write your L1 out here. Yeah, clicking. Are you getting my point, Chanvi? What was the mistake?
Yes, ma'am, getting.
Students, are you getting me? देखो वहाँ पे क्या हो? Now what we are doing is initially we are loading our register A with FF. We are sending FF to output port 2. यहाँ पे हम send कर रहे हैं. Then we are decrementing. We are providing a delay, right? Then we are checking whether our delay becomes 0 or not. If it is 0, it will go. If it is not 0, it will go and send it to the output port. मतलब ये आपका FF, FE, F0 जब तक ये 0 0 ना हो जाए तब तक ये आएगा. Can you see here, students? Right? So in that way, you can design a counter like this, where you are providing some delay in between two count. Now, Janvi, can you tell me कि आपने FF से लोड किया तो exactly 1 millisecond delay मिलेगा या कितना delay मिलेगा आपको? अभी हमने कैलकुलेशन किया था. If we are loading a register with FF, we are getting how much delay? We are getting how much delay if we are loading a register with FF? Yes?
1.7 millisecond.
Very good, right? It is approximately equal to 1.8 millisecond delay. So what it means, कि यहाँ पे instead of FF, I need to take some another value, right? ये loop मुझे 255 times execute नहीं करवाना पड़ेगा to get 1 millisecond delay, because if I'll execute it 255 times, I'll get a delay of 1.8 millisecond. Out of that, I need only 1 millisecond delay. That means this count should be different, right? So how to find this count value? That is our point. Now we need to discuss in our next lab कि हम लोग ये count value कैसे decide कर पा रहे हैं, right? How we will find that count value that we need to check for. Are you getting me, student? Right? अगर Shivangi, you want to say something? Shivangi? Shivangi, your mic is unmute. You want to say something? Okay. So thing is, whenever you are loading the register with the maximum value, you will get 1.8 millisecond delay. Now we need only 1 millisecond delay. That means we need to consider, we need to find the value of count, right? So by next lab, we will discuss two different technique. हमने दो already discuss किए. We'll discuss two more technique for generating a delay and how to find the count value, that we will discuss in our next lab. Are you getting me, student? Anything from your side?
મેમ
Anyone?
કોડ બતાવો ને તમે જે કર્યો તો.
मैं કર્યો તો એ
હા મારામાં મિસ્ટેક છે.
screen is visible, Janvi?
નો
Or I
મેમ.
need- So this is again not a final code because you need to find the value of count here, right? Okay. Okay. Anyone any last point to discuss? Now, if you want to design, Janvi, just one more minute. I'm discussing this and again I'll keep this. Now, done? Okay. Now, next question is how to generate a square wave or how to generate a waveform by using a counter and timer. A very interesting task or very interesting, you can say, program of generation of waveform by using counter and delay. Right? If you are here by next week, we'll see here on hardware. Right? हम लोग CRO पे ये observe भी कर सकते हैं. But in case if we are not here, we again have to go with the simulator only. Otherwise, we will execute here on our trainer and you will find how to generate a waveform by using this. Right? So basically, अगर आपको counter कैसे design करना है and how you generate a delay in between two count value, if these two things is clear to you, the point, the topic which is related to counter and timer is up and down counters design and generation of waveform. These 3-4 concepts you are able to understand, right? So I hope this thing is clear. Any doubt, any last point to discuss, anyone? Okay, just wait for one more minute. I'm taking the attendance and then you may leave for your next class. 6. Drasti,
Yes, ma'am.
Harish, Anil, Tulsi,
Yes, ma'am.
Smith,
Yes, ma'am.
Krishna,
Ma'am.
Vani,
Yes.
Pooja,
Present, ma'am.
Chanvi, she is present, Ritesh,
Present, ma'am.
Madhvan, Parth,
Yes, ma'am.
Isha,
Present, ma'am.
Siddharth,
Yes, ma'am.
Pradeep, Yashvi, Hinal,
Yes, ma'am.
Shivangi, Aman, Shubham, Mami,
Present, ma'am.
Punj,
Yes, ma'am.
Sachin, Rumil,
Present, ma'am.
Shreya,
Yes, ma'am.
Pranav, Mahek,
Present, ma'am.
anyone? Okay, student, you will leave for your next